It's time for another amazing chemistry video with Mr. Stapleton, proudly sponsored by Farmers Union Nice Coffee.
Hi guys, welcome to this video, which is going to be really a short one, just around thermochemical equations. Thermochemical equations are equations that we use in chemistry to show when there's an energy change involved, so whether we're talking about an exothermic or an endothermic reaction. Now, like any just sort of reaction equation you do in chemistry, the first two things that you need for it are the same. So the first thing you have to have is obviously the correct species. So by that, we mean you must have the right formulas for the reactants and the products. Okay, you have to have them correct. If you don't get that, you're not going to have a correct equation, so you're not going to get any marks in the exam. So the correct species is first, and then you need to balance it as you would any other normal chemical equation. All right. So those two steps are exactly the same. Nothing different about those. However, the two things that you need in a thermochemical equation which is different to a normal equation is firstly, you need the states. Okay? So by the states, what we're talking about is you need to write down if it's a gas, a liquid, a solid, or if it is aqueous. Okay? And it's really important to put those in. Okay? And the states are as they exist at room temperature. Okay? So water would be a liquid. Okay, CO2 would be a gas. Okay, glucose C6H12O6 would be a solid, because those are the states in which they exist at room temperature. The final thing you need to put in there is what we call the enthalpy value. Okay, so you normally write that as delta H equals, put your value in, and then you'd have kilojoules per mole. Okay. If it's an exothermic reaction, your delta H must have a negative at the front. If it's an endothermic reaction, and this is important, your delta H must have a positive. You actually have to state if it's a positive or a negative. Okay. So what I'm going to do is just quickly show you two different thermochemical equations, show you how we put each of those four laws in together, and then that'll be the end of the video. Okay, so what I've done is I've just got those four laws over here, so you can remember them as we go through. So correct species, we need to balance it, we need to have the states, and we need to have the enthalpy value. So the first one I'm going to do is the complete combustion of butane. And what I should talk about when we're talking about combustion reactions in chemistry is we assume they're complete. So your products are always going to be carbon dioxide and water. So I'm going to start off with butane, which is C4H10. Okay, so if we have butane, C4H10, we're just going to go through and put the right species in. So that, under complete combustion, reacts with oxygen to give us carbon dioxide plus water vapour. Okay, or water I should say. So what we're now going to do is we're going to go through and try and balance this equation properly. Just going to see if I can get all of that in the screen for you. Okay, so we're going to balance this equation firstly. So we've got 4 carbons here, so we put a 4 in front of that. Okay, got 10 hydrogens here, so we put a 5 in front of this. And this is the way you balance any sort of combustion equation. Do your carbons, your hydrogens, your oxygens at the end. So we've got 8 oxygens here, another 5 here, makes 13. Okay, now what you are allowed to do in chemistry is you're allowed to have fractions in it. So we need 13 oxygens here, which doesn't go nicely when we've got 2. So we need 13 oxygens. If we divide 13 by 2, and then we times it by 2, we're going to end up with 13 oxygens. So it's completely fine to put your fractions in there. Okay, so that's the equation. If we're going to write this as a thermochemical equation, however, we need to add in the states and the enthalpy value. So because I've run out of a bit of room, I'm just going to move over and rewrite it now as a, so that's a normal equation. Okay, what I'm going to do is now write it as a thermochemical equation. So we've got our butane, C4H10. Now butane is a gas at room temperature, so the state it's going to exist is as a gas there. Okay, we're going to add in 13 over 2 oxygen, and oxygen exists as a gas at room temperature also. We get from that 4 moles of carbon dioxide, which is also a gas at room temperature, and we also produce 5 moles of water, which is a liquid at room temperature. So we've introduced step 3, which is the states. The final thing is to introduce an enthalpy value, and for butane, we put it at the end, delta H equals negative 2,874 kilojoules per mole. So hopefully that's all showing up on the camera there, okay? But we've got this, the balanced equation there, we've got the states as they exist at room temperature, and we've got an enthalpy value of minus 2,874 kilojoules per mole. If I was just going to put in another one, which I'll show you, I'll do ethanol. Ethanol's a good example. We've been using that a fair bit, okay? So ethanol is C2H5OH. Ethanol, so we're looking at pure ethanol, exists as a liquid at room temperature. When you combust that in oxygen, which is a gas, okay, you get carbon dioxide, which is a gas, plus you get water vapor, which is, I almost did it wrong, which is a liquid at room temperature. It's not water vapor, it's water, all right? Balancing it up, you need 3 water vapors and you need 4, so 3 oxygens there, because we've got 1 here, okay? And the enthalpy value for that one is something like minus 1,324, I think. It might be slightly off on that one, but it's the same process that we've gone through, where we do our correct species, we balance the equation, we put the states in as they exist, then we put our delta H value. That's 4 points. Thermochemical equations in the Year 12 exam will probably be worth 4 marks, all right? 1 for getting the correct species, 1 for balancing. That's normal what you get for an equation. 1 for putting the states in, 1 for having the enthalpy value. Key is to remember that your states are how they exist at room temperature, and your enthalpy value must have a positive or a negative depending upon whether it is endothermic or exothermic. All right, hope this has been helpful. As always, if you've got any questions, just ask. Thanks, guys.